Hi, this is the ignition series of the explosive resonator set of videos. With the old style pulse jets, an ignition system really wasn't necessary. This is showing one of the original NAX series. You could throw a piece of paper behind it and on fire, and it would start up and run. The ignition placement or anything like that wasn't important at all. The pulse jet would start and run without ignition except for starting. Once it got started, it would run fine. This is the first explosive resonator. It was found with an explosive resonator, the ignition system was very important. With the explosive resonator, it was found that not only did you need an ignition spark for starting and for running, but it was also important where that ignition spark coil or the ignition spark plug was put in relationship to the combustion chamber. Now what I'm doing, this one here was invented by accident. The explosive resonator was invented by accident. It was first made to double check the valve assembly setup. This was originally supposed to be a full-length 3-inch motor, but it ended up becoming an explosive resonator at about 14 inches. It normally would have been about 30 inches. The valves were not a success. Since the valves weren't a success, a regular Venturi type plate was made to fit over the big opening that the valves used to go into. And it was at this point basically that the explosive resonator was invented. This was the first motor to exhibit the string of explosive pulses that I was looking for. This cobbled up machine did what I'd been looking for. This is the basic dimensions of an explosive resonator M37, which is the model 37. You can see that 2 to 2.5 inches back for the exhaust or for the spark plug is where it worked the best. If you put it farther back, it runs backwards, and if you put it farther forward, it doesn't run at all. This is a standard Snappy Boy Snappy Jet ignition system. This system was used and sold for years. It's a good system. It uses a relay, a car capacitor, a 12-volt battery, a car coil, and a spark plug. It doesn't need any parts really that you couldn't make or get out of a car. This is a schematic of the relay. It needed a double pull, double throw relay, and it needed to be a 12-volt relay. At Radio Shack you can get this relay, and it's I don't know, whatever it says there. You need a 12-volt relay though, because a 120 or a 241 won't do it. Now the autocoil, you just go in and get one. get the cheapest one you can get. When I went in, the Wells C819 was probably the cheapest one they had. A capacitor, any automobile capacitor. Beetles have them and Chevys, but it's the older ones that have them. This is the standard ignition unit. Now, I have 2 coils mounted on this, and you can double them up and get 2 coils out on them, because I'm doing a lot of experiments with 2 motor, or yeah, like a double explosive resonator type deal, especially for the Jet Sticks and Silver Surfer model. And that there is the coil. I'm kind of touching my finger, and there's the relay. The relay might not be real familiar to a lot of people, but all you have to do is hook it up the way it shows. And there's a capacitor. Everybody's seen one of those probably in a car, old car or something. Don't try to use an electronic one. Just get one. They're only like $3 or $4. And I think what I'm trying to show here is how, well, there we got it all together. Now, it looks like quite a mess there, but once you get it all hooked onto your flying vehicle or whatever you're going to use, all that mess kind of goes away. Now, make sure that you have the spark plug or motor grounded, because if you don't, that spark is going to go through you, through the handlebars and right through you, and you can feel it, and it's not a pleasant feeling. Now, I think here what I'm trying to do is I'm testing that, trying to show the spark. The spark was weak, and I messed with this thing a long time to try to get it to go better. And that was okay when you were just using the pulse jet motors, because if it hit, it didn't have to hit real dependably. But if you got some spark in there, which it does spark, but it wasn't too good, and not enough for an explosive resonator. And what I'm going to show you now is what happens when you have an ignition system that isn't firing or isn't giving a dependable spark. This is what happens when your spark making apparatus is not sufficient. Nothing. I thought that the spark ignition system was fine. I didn't think anything was wrong with it. I thought I was getting a good spark, yet the motor would not start. So I thought there was something wrong with the fuel system, and I thought there was something wrong with the motor. And I ended up changing the motor and putting another motor in there to see what was the problem, one that I knew worked, and it wouldn't work either. So I finally decided that yes, it was the ignition system. So that's when I decided that it was time to get out there and find something better. In this experiment, a straight tube explosive resonator has arms welded on it radially, and the idea was every time it went around, the spark would touch the spark plug, and it would explode, making these arms go around fast enough to put a propeller on there. And I was looking, it was an experiment looking for different ways of getting you know, off the ground with it. And but the old ignition system really wasn't up to the job. It actually didn't work at all in this experiment. So therefore I didn't get any useful experimental data from this design at all. And this design could possibly be a good one, but don't know, because I didn't have an ignition system good enough for an explosive resonator at that time, nor did I understand that I needed a better one. I thought the old one was fine because it worked for everything else. Okay, so I'm tired of not having a good enough ignition system, so I'm going to go to Radio Shack and get enough stuff to make one. I'm going to show you what I got, because it's important for you to be able to build ignition systems, troubleshoot ignition systems, and use these ignition systems if you're going to build pulse jets or explosive resonators.
Electronic system. I'm going to go video your parts. Is that okay? Okay. See? Everybody's all friendly and willing to help.
Let me make sure behind our journey.
Okay, here we are. We're at Radio Shack. And what we need... We're going to use the 555 timer. I think they're over here. Let's see here.
Yeah, you're fine, sir.
You're not?
Yeah,
Okay, good. Thanks. Can use 18 pins. That'll fit right into our board. I'm gonna get us a little board here. Well, get this one. Get this one. Get this one. We can get this one. Here we go. Okay, we need a 555 timer, react, solar cell. Here we go. Look at this. This is such a popular thing. They put a great big package on it. Well, I've been burning these out pretty regular, so it's a low power deal. One of them. If I burn another one out, I'd be kind of pissed. I'd probably give up on that system. Transistor. That's a 2N3055. Let's see if we can find for that. 2N3055. Well, that's a pretty hardy little job there. Is that right? I can get that thing to run a relay. It's rated at 1 amp. We need about 12 volt.
Okay, no, I'm not about to.
This one's rated at 10 amps. This will do it. That go 0 to 10K. 1K, 100K, meg. All kind of big. Okay, how that thing work? What else we got here? Over here. Here's knobs. Wow, 10 ohm resistors are pretty good size. Ohm, 10 ohm. And capacitors. One is 0.1 something. Very big. Well, with the stuff I've got.
In this experiment, I tried to use a 12-volt transformer run out of the wall to run my spark coil and spark plug, so I would get a better thing. And this would work fine in the house, but it didn't work because my transformer was burnt out. So that experiment didn't get me anywhere, but you got to keep trying. Now here's my little pile of stuff that I got from Radio Shack there, and my piece of paper with all my different designs on that I picked up from here and there. So I've got a pretty good hoard of stuff there, plus I've got a bunch of stuff that I already had. So I'm going to start experimenting on making a better ignition system. Now when you're trying to use the 555 timer, I've used it before a lot. I invented a pressure transducer material, and I've used it before, but I didn't remember exactly how it worked. So what you want to do is you want to go with a simple design first. Now make sure you get yourself a whole bunch of little LED lights, because that'll tell you exactly what's going on in that 555 timer. Now, as I remembered, and which I have proven, you change the frequency that it turns on and off by the capacitor and the resistors. And I knew that, but I didn't know which one did what and what happened there. And that's what we're going to go through, so you'll know all about the 555 timer, because it did actually, I am using it because it seems to be pretty good. And then so you'll know how to use it, how to put it together, and what it's supposed to do. And we'll get right on with that. So I put all my stuff together on my little board there, and I tried using the relay, and on and off quite a bit for about 2 weeks. I experimented, re-experimented, burn up parts, did a lot of work on trying to get the thing to work right. And now right now you'll see it's flashing slowly, and that's because that big capacitor there is it takes longer for it to charge up. And then I'll end up changing that capacitor to different sizes and all the different resistors and stuff, and I'll burn up quite a few parts. That relay will burn up, and but I don't know when, but it does. Now I don't have an ignition coil or anything hooked onto this. Right now all I'm doing, and probably what you'll need to do, is to just find out how to make that light blink on and off at the right rate. Or, you know, not too fast, not too slow, get an idea where it belongs. The best sparks I got were using a relay, and with this size capacitor, this is how fast that it would blink. That there is about a, must be about a 4.7 UF. Now I'm putting in what I think is about a 1 UF. And let's see. Now we're getting a faster rate. See how changing that capacitor. Now that's from pin 2 to ground. If you use the electrolytic capacitor, you want to make sure that the negative side always goes to negative, because supposedly they will blow up. I haven't seen one blow up, but they say they can, so you want to hook them up right. Okay, again, I'm putting in a little bit larger capacitor. That's a different type, so it looks like it would be bigger, but it's not really. And it actually is looks like smaller because the flashes are faster. And that's a little bit slow, but that's about how fast you want your ignition coil to be firing for your spark plug. And once we determine the size of the capacitor that goes from pin 2 to ground, then we'll start working on the different resistors that go between pin 7 and pin 8. In this view, I probably haven't hooked up the at least the relay is probably not driving the LED. It's probably coming off pin 3, which is the output pin. So it would just be a resistor, because if you don't use a resistor, the LED will burn out because it's 12 volt and that's too much for it. So I was using about a 330 ohm resistor between pin 3 and then the positive pin of the LED, and then the other lead to the LED goes to the ground. And that is at least showing me that the 555 timer is doing what it's supposed to do even before I get it to do anything else. Now, with the old standard ignition system, we didn't use any electronic parts. We had a magnetically driven relay and a capacitor from an automobile and a coil from an automobile and a spark plug and spark plug wire from an automobile. And it works fairly well, but it doesn't have the points in the relay degrade over time and use. And when the relay is new, you pretty much can't beat this system.